Arrays are like vectors. We can define the type and a certain size for them. However, they are not flexible like vectors. Vectors can dynamically grow. Arrays are fixed in size. So when I declare a vector, I can just declare the type of it and the name of the variable and square brackets. And inside them, I can choose the size. So I can either choose 10 or I can choose another variable, but it has to be a constant expression, which means it should be evaluated at compile time. You should get an error depending on the compiler when you use a variable or using a function to get a certain size or anything similar to declare the size of the array. Like using this one right here, a non-const expression would lead to an error, but using the SZ, which is a constant expression, and using a constant expression function is also alright. And we can declare an array of pointers. The elements inside it are pointers. And we can use arithmetics between the square brackets. Like in this example, we are multiplying 4 by 7, decrementing 14, which would get us back 14. We can see some random numbers because we didn't initialize it. Once we initialize it, it should be just zeros inside. And we can add just one element inside the array, and the others would be filled automatically by default values, which is an empty string in this case. And we can declare an array of strings without initializing it. And we can declare a list of characters, which is like a string but without a null-terminator at the end. We can add a null-terminator at the end of it to mark the string as ended, or we can do it this way. The null-terminator would get added automatically, as we can see in the debugger. And adding more elements than the size we have declared is going to cause an error. We should make it into 7, fit the whole string inside. We should leave a place for the null-terminator. And in this example, we have an array of 3 elements. We can't initialize an array with another array. We can't make them equal to each other, just like that, just like vectors. And we cannot declare an array of references. And to declare a pointer and initialize it to an array, we first have to wrap it into parentheses, and then afterwards do it normally. We just assign it to the address of the array, and it would point to the elements inside the array. And to declare a reference, we do the same thing as the pointers. We just replace it with an address of operator, and we assign it to the array without the address of. And we can have array of references to an array of 10 pointers, which means that it would hold the memory addresses of all the pointers inside. If you look closely, we can see they both have the same memory addresses. Let's look at index 2 has this memory address and there. And to print the values inside the array, we just use a range-based for loop, and we can use a normal for loop, which is the indexed one, to print the values. For the indexed for loop, we can use the std size to get the array size. If we don't want to just use a number like 10, or depending on the size of the array, you don't have to specify here the number exactly, or we can use 10 if you want, and we print them just like that. It's going to print everything inside. And we can initialize a vector, which is this one right here, ivec, and it would copy the elements from the start of the array, which is the integer array, which is the integer array right here. So using iterators, we can get the beginning of the array to declare a copy to initialize a vector that copies the elements inside the array, or to copy the elements from another vector into an array. We can just declare an indexed for loop, and we can assign each value inside the array to the values inside, which makes sense. The C++ primer book tells us not to use pointers and arrays. Instead, we should use vectors and iterators, and use strings rather than the C-style, the array-based character strings. To declare a pointer to a certain element inside the array, we start by writing the type and the pointer, and then the name of the variable and the address of operator, and then we access the array using the square brackets, and we choose any element we want inside the array. Or we can do it in another way where we can just remove the square brackets, and let's name it num1, and we remove the address of operator, and you can see that they both point to the same address. Or we can do it in another way where we write the pointer and we name the variable num2 as an example, and and we use the array inside the parentheses, and that would give us the first element inside the array. And we can see in the debugger that they are all the same. And just like pointers, when we dereference it, it's gonna change the element value inside the array. As we can see in the debugger, it has changed all the first elements to a instead of 1. And there's also another way of doing it. We just write the address of and the first element the same way as we did this one, which would do basically the same thing. Incrementing a pointer would move the pointer one place inside the array, so it will move it to the second element if it's pointed to the first one. And decrementing it would result in the same process, but reversing it by one element. And we can initialize a pointer to the element that is past the last element inside the array, where we use the end. If we have a vector, we use the dot end, or in this case, if we have an array, we can use the std end, and we pass in the array, and that would give us the last element inside the array. And we can declare a pointer, and it can point to an element of the end of the array, so after the last element inside the array, which would give us the same result as using an iterator to point to the end of the array. And we can use it in a for loop. So if we have an indexed for loop, we can declare a pointer of type string, and we initialize it to the first element inside the array, and we can compare it as long as it is less than the last element. So we can either use the end or use the num. They both point to the same end. And we can see out the elements inside by dereferencing the I. And you can see here the console log. We can see they have printed 1, 2, 3. And we can have a pointer to the beginning as well as the end. And we just use the std begin and an array. And in this way we get the same thing as pointing to the first element. We can use a while loop to check if the beginning didn't reach the end. And we can just increment the beginning. That would break out of the loop. After breaking out, we can console log something broke out. And you can see it here that it's broken out of the loop after the beginning reached the end. To get the length of a certain array, we can use the iterators. We can decrement the end from the beginning and we would get the result. So if we did that, we are going to get 3, which is the length of that array. And array. In C++, when we subscript an array, when we access its elements using the square brackets, like in this example, when we are subscripting the second index in this array, what we are actually doing, we are using the memory address of it and we are incrementing 2 to it. So behind the scenes, it looks like this, where P3 is the memory address and we are incrementing 2 to it. And then we are dereferencing it. So it's a pointer to that element behind the scenes. So it's not like Java or Python where we have array indexing feature. Multidimensional arrays are basically just an array. Inside each element in that array, there's an array, a specified size. And we specify the size of the second array that is inside the first one, where we can see here as an example, there are 4 elements inside each array. So basically, if we initialize it with values, we can specify like this, 1 and then 2 and then 3, which would only initialize the first element inside each one. So if we want to complete them, we can say 1, 2, 3, 4, and here 2, 3, 4, 5, and here 3, 4, 5, 6. And if we run the debugger and see, you can see each one has, the first one has 1, 2, 3, 4, and the second one has 2, 3, 4, 5, and the third array has 3, 4, 5, 6, as we can see here in the declaration and initialization. And they can also be 3-dimensional, so I can even add like 2 elements. If we check now the debugger, we can see that now the internal array has also arrays in it. So the internal array, if you open it, you will see 4 arrays, which are those things. And inside each array, there's 2 elements. You can see here, they are initialized until the compiler doesn't see anything afterwards. It will add zeros. And to make it look better in a 2-dimensional way, that's how it looks like. I think this one is more readable. So in 2-dimensional arrays, if we have an array of size 1, which has 3 elements inside it, so if we access the first element, which is going to be an array, so it's going to have this whole block, this whole table. When we write this subscription, the 0, the first element subscription, we are going to access the whole table, like this table right here. To access each element inside that table, we have to write another square brackets, since we have a 2-dimensional array. So accessing the 0 and then 0 is going to give us access to this element inside the table. And the same way, when we access the first array and then the second element inside it, we're going to get the second element, and this one for the third one. And if we change the size of it to 2, like it has 2 arrays inside, we can just duplicate this and we can change only the numbers. Like this one, we access the second array in the array R, and here we need to also change all the numbers from 0 to 1, and we can keep the secondary square brackets without changing the numbers inside them. So now we are accessing the first element inside the second array. If we initialize it to 0, 1, 2, 3, 4, 5, 6, it will do it sequentially. The first 4 elements inside the first array gonna be 0, 1, 2, 3, and the 4 elements inside it gonna be 4, 5, 6, 7, and the last one gonna be 8, 9, 10, 11. Or if you add it without extra braces, only the first braces is gonna do it sequentially like I said before, where the first array is gonna have 0, 3, 6, 9. And if I have a 3-dimensional array and I want to access the first element in the array, so in the third array, the first element inside it, I can access it using 3 square brackets where we get a 0 because all elements inside this array are zeros, and I can assign the element inside another array to that value. Declare an array of references to the second array of this array. The values would be 0, so the values would be 0 inside it. That's how we do it. If we initialized it to the first array, we would get the same result here, as you can see, 0, 3, 6. To loop over a 2-dimensional array, we can use an index for loop, and what we have here are 2 constant expression variables of size t, which means they are long unsigned integers, and we define them as having row and columns. So we have 3 rows and 4 columns, which means inside this array we have 3 arrays and 4 elements inside these arrays. And we need to have 2 for loops. As we can see in the outer for loop, we are going to check it against the row count so we can access each array inside the array. And for the second one, we will also need to use the std size t, and we name the variable to g, not I, and we check it against the column count, and we can check it as not equal to, and here we increment j. And afterwards, to access the elements inside each array, we have to use the bracket first, the I, which is for the arrays inside, and the inner one to access the elements inside each array. And now we can just do anything we want with them. We can just add 1 to each one. So all the values inside the arrays are zeros. We first start with the first array, which is gonna be if5 0 and 0 as well. So I is gonna be 0 and j is gonna be 0. So now this element will become 1, and you can see it has changed to 1. And now we are stuck inside this for loop. When this for loop runs once, this for loop is gonna run 3 times because it's 4. When it reaches 4, it's gonna break. So now it's gonna go inside again, but check 0, 1. So this variable, it will add 1 to it, and it will check the next one to add 1, and the next is gonna add 1. And now it breaks out of this for loop, and it's here. So now it's gonna increment I, and I would become 1. So now we have to shut the first array, and we open the next one, and now it's in the second array, and it's gonna add 1 to the first element inside it, because now we have I as 1 and j as 0. So this one is gonna become 1, and now we are at the next, so this one is gonna become 1. And this is the process. It's very simple. And if we have a 3-dimensional one, we should add a grid, a grid count equals 2. So now we have 2 grids, and we add the grid count first, and now we have a 3-dimensional array. And now instead of doing this, we just remove, or we can cut it, since the grid is the upper one, so we need to start from the outer one. So grid is going to be the outer for loop. So we create a for loop and we wrap it over those for loops. So now we have 3 for loops, and we start from I. We change the type to it to size t, and change the variable name to x, and we change that to grid count, and we increment x. And now in the deepest one, which is the column count, we are gonna access these elements. So I f5 and then grid count, so x, then I, then j, then we can increment 1. And now it's the same process as a 2-dimensional array, with just 1 extra dimension. So now we have 2 arrays arrays, and inside these 2 arrays there are 3 arrays, and inside each of these arrays there are 4 elements. So now when we run it, the upper one, the outer one is gonna run once, and it's gonna run also the second one once, and now we are in the inner one, which is gonna run 3 times, and it's gonna use 0 and 0 and 1, and it's gonna increment that one, and now into the next one, which is 2, so 0 0 2, and it's gonna increment it, and it's the same process. It will break out. It will check now if I is not equal to row count, which is true, so it's gonna increment I, and now we re-access the next element inside the rows, which is this one right here. It's gonna access it, and it's gonna increment all its values, and that process will repeat until we run out of rows, and then it's gonna change to the next outer array, and it will access each row inside it, and it will increment each column. And we can use range-based for loop for a 2-dimensional array or 3-dimensional. It's the same way. We just declare the auto. We have this array IA, which has 3 rows and 4 columns, as you can see them, and we just declare a range-based for loop, and inside this for loop we are gonna access the row right now. So instead of using indexes, we can just use the row we have just declared inside the for loop, and we use auto and then the address of, let's say, column, and column inside each row. And now we can increment, let's say, ++ call, and now it will increment each value inside the rows by 1. And if we look inside the array, we can see that when it increments it, we can see the values changing inside each column. So it became 2 3 4, and the 3 would become also gonna just add 1 to each column. For the range-based for loop to work with a multi-dimensional array, the outer one should be references. So the rows, as in this example, like this array, should be a reference. So if we remove the reference, we are gonna get an error because we would get a pointer instead of the array. So we have to use references, and for this one to work on it, it also has to be references. Otherwise, we'll get a copy of the elements inside. And we can use pointers, like in this example, if I declare a pointer to the first element inside IA, and then I can check if that pointer is not equal to IA plus 3, and then I can increment that pointer. And for the inner one, we have to work with that pointer that we have declared. So let's say auto, which is column equals p, dereference p, and while that column is not equal to p, and the same way we did it, we'll just add +4 because we have 4 elements, 4 columns, and we increment column, and now I can access the column and increment it by 1. So as you can see, the dereference p has 1 2 3 4, which holds these elements. So column is a pointer to the first element, column is a pointer to the first element, which is 1, and now when we add 1, it's gonna become 2, and you can see it here inside the p pointer, it became 2, and if we check IA, which is the original one, it became 2 as well. And now it's gonna increment the column, which is a pointer which holds a memory address, and if we increment that memory address, we are gonna move to the next element in the array, and then we dereference it. When we dereference it, we are getting the value inside that memory address. So it's now incrementing all the values. It's a bit confusing, but you have to try it out to get it. And lastly, we can use a for loop with iterators to access each index. I can use auto and then I, and then std begin for the IA, and we check if I is not equal to the std end of IA, and we increment I. And now inside the for loop, the inner one, we have to say auto, let's call it column, and it should hold the beginning of the array inside, so I, and we have to dereference it to get the actual elements, and we check if it's not equal, so column is not equal to the end, so std end, and of also the dereferenced I, and then we increment column, and then we dereference call, and we can increment it by 1. And it's literally the same as the pointers, but just using iterators. But it's the same logic. So now I is gonna have the first array inside the big array, and the column is gonna have the first element inside it, inside the inner array. And yeah, it has 1. If we increment it, it's gonna become 2, and everything will change inside. This one became 2 as well. It's the same as pointers. It works exactly the same way. One last thing. Let's assume we are not using auto here, and let's say we are actually typing a it like it should be typed instead of using auto, which is the easy way. So the way we should type it is doing this. So this way. So now the actual type is like this, looks like this, like the way we declare this variable, which is the pointer. So instead of doing this, we can actually type define it. So we can use the type define and then int, and then let's say integer array, and it's of size 4. So now we have defined it, and instead of doing all this or using auto, let's assume that we can't use auto for some reason. This way would be also a viable option. And yeah, if you wanna really define it instead of using auto, or you can use using integer array instead of this. So if we remove this, so instead of using that, we can use using integer array, and then we can initialize it to an array of 4 integers instead of writing it like the ugly way where we wrote it before. And you can also use it in this for loop, range-based for loop. So we can use integer array, and it would also work. And arrays can take minus values as indexes, unlike vectors. If we try to subscript a negative value, we're gonna get a warning or an error that you're accessing an element out of bounds, and it would cause an error. Unlike arrays where they take a minus value, and if we use a -2, we are gonna get the first element inside the array, which is 0. On P5, if you look at it, where we have a P5 as a pointer and it has 2 to it, so the third index. So if we decrement 2 from it, we're gonna get the first element. And if we use -1, we are gonna get the second element, which is number 2. And that's how arrays work. In C++, a string knows exactly how long it is because it manages its own size. But in the C language, a string is just an array of characters. So the computer has no built-in way of knowing where the string ends. We have to tell it exactly where it ends. And we do this using the Null-Terminator, which is a \0. We add it inside single quotes, and we add \0. Because if we didn't, we are gonna get an error because the compiler has no idea if that string has ended. When it has no null terminator, this built-in function which would return the size of that array, if it doesn't know where that string has ended, then we are gonna get an error because it's not gonna stop reading at this character. And it's gonna keep continuing with every garbage values there's inside this array. When we use the strings and we compare them, the compiler knows that this string, depending on the alphabetical order of the letters inside, it's gonna give us an answer depending on what's the order or who's actually less than the other. In this case, it's false because S2 is less than S1. If we do this, the same process between two const characters arrays using the old C-style arrays, this will be a memory address, so you can't really compare them. So you're basically just comparing two memory addresses. This doesn't make any sense. If we wanna do the same way as comparing two strings, actually comparing them to get a result, we use the string compare, but it's clunky because you don't really know which one are you comparing, so you have to remember the values that you are gonna get, which is either 0 or 1 or -1. So in this result we are getting 1, but you have no idea what 1 means, so you have to look into the documentation. If we compare as an example banana and apple, then banana is gonna be the greater one, which would return 1. B is larger than A, comes after A, so it's greater than A. It's gonna return 1. If they are actually both equal to each other, we are gonna get a 0, and if the first string is less than the second string, we are gonna get a -1, which you can see here in the result. When we use the C++ strings, it's fairly easy to concatenate two strings together without worrying about the sizes, but in the old C style you have to manage the size manually, so you have to know first of all how many strings are you concatenating. So in this case, if we have CA and CA2, they are approximately 35 characters. You have to combine the sizes of them, and then to concatenate them, you should first start with strcpy, which would copy CA1 into large string, and then you have to add space to it between those two words or two phrases or two strings. You have to use strcat and then again strcat, and to add the second string into it. And if you have any error, you're gonna get a buffer overflow because there is no memory left to add these strings together, to add these strings inside the large string array. I deliberately made it smaller so we can get a buffer overflow. Let's change it to 20 and see what happens. I think modern compilers, they don't really cause any errors or buffer overflows. I don't know how, but they are smart. So you can see here that it didn't actually add all the elements inside, but still it showed us here that it is complete, which is weird, but apparently it works. So depending on your compiler, you're gonna get it. Anyway, don't try this at home. Like, don't do it anyway, even if the compiler accepts it and doesn't cause any errors. And using the technique we learned earlier in arrays, using a pointer to the first element in the array right here, which is an array of characters, and we can have a pointer and we can check if there's no Null-Terminated, so the string has ended. We keep printing and we keep switching to the next character inside the array until we hit the Null-Terminated. Then we're not gonna enter the while loop. And we cannot have a pointer to a string character, so this inside the string we have characters that we don't see them, but if we access this one as an example, now we have access. Now we are accessing the first character in the string, but we can't have a pointer to it, so we can't have the memory address of that character, but we can have a copy of it by declaring a character string and accessing the index, whatever index we want. But we can do it in another way where we use the built-in function that would return a const pointer to null-terminated content. And they tell you exactly in the documentation that we shouldn't modify it or do anything with it that would modify the value of the string. But since it's a constant pointer, we can't really change anything inside it. And it would return for us the first character inside the string.